So first we'll discuss Unit 2 MCQs. Okay. So first we'll start with Unit 2 MCQ. This is June 2021 exam paper. The first one is which is correctly labeled a reaction profile of an exothermic reaction. Exothermic reactions, reactants have high energy and the product is having low energy. So it cannot be C or D. And from reactant till the start of a reaction, we label that as activation energy. And from the reactant, the difference between the reactant and the product, that is known as the enthalpy change or energy change. So it matches with option A. Why not option B? Because in option B, the enthalpy change reactant to the product is enthalpy change and reactant till the start of a reaction is activation energy. So A should be the right answer for this. The equation for a reaction is shown. Carbon react with oxygen, give carbon monoxide, which is the correct symbol for enthalpy change of this reaction. Like here, when we talk atomization means, the term atomization means when we have a like a substance is there, solid, liquid, or a gas, but we produce atom in a gaseous state, we call atomization. So this is not atomization because the atoms are not produced here. Atom of an element is not produced or in a gaseous state. Combustion means when we burn 1 mole of a substance. Like if it was carbon react with oxygen and it gave carbon dioxide. So carbon is a fuel. So when we burn 1 mole of a fuel, we call enthalpy change as an enthalpy change of a combustion. In that case, but here we are not burning 1 mole, we are burning 2 moles. So actually it is twice the enthalpy change of combustion. The enthalpy change of formation, enthalpy change of a formation means when we produce 1 mole of a compound from its element. So we have the element here, carbon and oxygen are the element, and it is forming a compound. But what is the mistake here? That 2 moles of a compound is formed. So actually it is twice the enthalpy change of formation of carbon monoxide. Like 2 moles of the carbon monoxide are formed. So that's why it is not enthalpy change of combustion of or a formation of a carbon monoxide. It's a twice the enthalpy change of formation. So if none of this, then simplify. Like if you are not able to categorize the reaction, what we can simply say, we can say this enthalpy change is simply the enthalpy change of reaction. That's why D is the right answer. So if you are not able to categorize the enthalpy change, we call that as enthalpy change of a reaction. In question 3, the graph shows how the concentration of iodine changes over a time. What is the value of a rate at 8 seconds? So at 8 seconds, how to work out the rate of a reaction is you have to draw a tangent here. The gradient of a tangent gives us the rate. Length of a tangent, it's up to you. You can draw longer or shorter, it's up to you. So the change in concentration, like just take a gradient y2 minus y1 over x2 minus x1. So first value on x-axis, that is x1. The second value on x-axis, that is x2. The first value on y-axis, that is y1. And the second value on y-axis, it's y2. So y2 minus y1, so it is 10 boxes equals to 0.1, each is 0.1. So this is 0.2627 and this is about 28. So the y2 is 0.28. Each value is 0.01, each box. Minus y1 is 1 box above, so it will be 0.21 divided by x2, which 10 boxes equals to 4, so each is 0.4. No, you cannot divide 0.25 with 8 because to work out the rate at a specific time, you have to find a gradient. You cannot get the rate by just concentration and time you divide, you get the rate. No, that if it was a straight line, then only it can be done. But in this case, you cannot do. You have to draw a tangent to find the rate at a specific point and find the gradient of the tangent. So x2 10, it's about 10.8 because 10 boxes equals to 4, so each is 0.4, and this is, so when we subtract 0.07 divided by 10.8, so this will be 6.8. So 0.07. So we have 0.07 divided by 6.8. That is 0.010, which is A. So A will be the right answer for this. So whenever you need a rate of a reaction at a specific time, you have to work out a gradient. You cannot just concentration divided by time does not give us a rate, because concentration divided by time is, when it's a straight line, it will be correct. But when it is a curve, then the rate is continuously changing. So you have to work out by drawing a tangent at a specific point, which is given in the question they ask, or they will mention, sorry. The solid line of a graph below of a Maxwell-Boltzmann distribution. A Maxwell-Boltzmann distribution graph shows how the energy changes for the like how the energy is distributed among the particles. Which row shows a correct Maxwell-Boltzmann curve and the activation energy of a reaction at a high temperature with catalyst? Like this is the original one. This graph, the continuous graph, and this is the original one. But what will happen if we increase the temperature? What will happen? The peak will decrease and it will shift towards the right hand side. So if the peak should decrease and it will shift towards the right hand side. So that is why. And whenever we use a catalyst, what catalyst will do? The catalyst will lower the activation energy. Sorry. So the new activation energy will be lower than the original one. So it will be Y, the curve will be Y, and the activation energy will be W. So in that case, C will be the right answer. So, and if the same question was there, if we are decreasing a temperature, what will happen? The height of the peak will increase and it will shift toward the left hand side if a temperature is low. But if a temperature is high, it will shift towards the right hand side. In question 5, what is oxidation number of a chromium here? How to work out the oxidation number? Because this is a compound with an overall no net charge is there. So one sodium is +1, chromium is X, and oxygen is -2. This is each. So there are 2 sodium, so it will be +2 because one is +1. And 1 chromium is X, so 2 chromium, it will be 2X. 1 oxygen is -2, so 7 oxygen will be -14. And because the overall compound is a neutral, that's why the net charge should be 0. When we simplify this, +2, so this will become -12. -12 move other side, it will become +12. So 2x is equals to +12. If we need x, so x is equals to +12 divided by 2, which is equals to +6. So D will be the right answer. If it was not a compound, if it was a molecular ion, then the net charge should be equals to the charge on the molecular ion. In an oxide of a nitrogen, oxidation number of nitrogen is +4. Which one is oxide? They mention oxidation number of nitrogen is +4 and oxygen belongs to group 6, so it has -2. When we simplify, so this should be 2 and this should be 1. So it should be NO2. But there is no option of NO2. What could be the other possibility if you check? Because all of them compounds are, the compound is a neutral compound. So when we work out the total oxidation number, we should get 0. Like if we talk about this one, N2O, If a nitrogen is +4, one nitrogen is +4, so two will be +8. And one oxygen is -2. So means the net charge on this should be +6, but there's no net charge written, so it cannot be A. When we check B, which is N2O3, each nitrogen is +4, so two nitrogen will be +8. So each oxygen is -2, so three oxygen will be -6. So again, the net charge should be -2, but there is no net charge written, so it cannot be B as well. When we check C, which is N2O4, each oxygen is +4, so two oxygen will be +8. Each nitrogen is +4, so two will be +8. And each oxygen is -2, so four will be -8. So we have plus, like here you can see what is the net charge is 0, so it will be a molecule. That's why C should be the right answer for this. Why not D? Like C is the right answer, but why not D? If you check D, N2O5, each nitrogen is +4, so two nitrogen will be +8. Each oxygen is -2, so five oxygen will be -10. So there will be a net, there should be a net charge of -2, but here no net charge is given, so it means only C is the correct answer. Because all of these oxides, the net charge is, there is no net charge written. So when we sum the oxidation number of a nitrogen and oxygen, we should get 0. But we are not getting a 0 for other cases, only in option C. Hydrogen peroxide break down into a water and oxygen. In terms of oxidation and reduction, how hydrogen and oxygen change in this reaction. So hydrogen peroxide is H2O2. It decomposes and forms water and oxygen. What is the oxidation number of hydrogen? +1. So two are there, +2. So because this overall, this compound is neutral, so the total oxidation number of oxygen should be -2. So each two -2 for two. So each will be -1. So each is -1. Here, when it is forming the element oxidation number is 0. So for hydrogen, the +1 becomes 0. If +1 changes to 0, what we call hydrogen is reduction. And for oxygen, it is -1 because we check individual. -1 becomes 0. So -1 has increased. So for oxygen, it is oxidized. So hydrogen is reduced and oxygen is oxidized. Is it clear? This question 7. No, it is producing, sorry, the product is by mistake, the product they mentioned break down into water and oxygen. Sorry, because with reference to that, if you see H2, how oxygen is -2, look here. This is a hydrogen peroxide. The hydrogen peroxide decomposed to water and oxygen that they mentioned. Each hydrogen is +1. So there are two hydrogens, so should be +2. Because this is a neutral molecule, it's a neutral molecule, so oxygen, the total oxygen should be -2. The total, because this whole compound is neutral. So if the two of oxygen have -2, so each oxygen will be -1. Like two oxygen, the total is -2. Each will be -1. Then it is forming water and oxygen. I thought it was forming hydrogen and oxygen, but here it's water and oxygen. So when we write the oxidation number for hydrogen, it is +1, 2 will be +2, so oxygen is -2. And here it is 0. So when we check the change, we always check the change for individual. So for one, so hydrogen is +1 before and after, so hydrogen there is no change, unchanged. But for oxygen, which is -1, become -2, so reduce. And -1 becomes 0, so it is oxidized. So oxygen is being oxidized and reduced, where hydrogen is, yeah, oxidation number. Look, the oxidation number, there are possible oxidation numbers when we talk about groups, especially for the non-metals. Oxidation number, like example, for group 4, can have from -4 to +4. Group 5 can have from -3 to +5. Any number. Group 6 can have from -2 to +6. Group 7 can have -1 to +7. So oxidation number is they can, because if two non-metals combine with each other, so one of the non-metal will be a positive oxidation number, the other will be negative. So oxidation numbers of non-metals can also be positive. Yeah, it can have any number between this range from -2 to +6, or you can say +6 to -2. Several factors affect the ionization energy. The number of the proton, if we increase the number of the proton, it will affect the ionization energy. The outer electron in the further from the nucleus, amount of shielding increases, number of unpaired outer electron. Which factor explain the decrease in ionization of group 1? As we go down the group, why the ionization energy decreases for group 1? So we have to check which one is explaining why there is a decrease. So there is an increase in proton number. Like when you check for a lithium, there are 3 protons. For sodium, there are 11 protons. For potassium, there are 19 protons. So as we go down, according to this theory, it should increase, but it is not increasing, it is decreasing. Like if a number of the protons are increasing, the ionization energy should increase according to this. Like number of proton increase can affect the ionization energy. But in this case, for a group 1, as we are going down the group, even though the number of the protons are increasing, but what we observe about the ionization energy is decreasing. The outer shell is further from the nucleus. That is right, because in a lithium there are 2 electron shell, in sodium 3 electron shell. So the electron, the valence shell or the last shell is far from the nucleus. That is why it becomes easy to ionize. Amount of the shielding increases. That is also shielding effect means like how many inner shell electron. The first one is having only 2 inner shell electron. The sodium will have total 10 inner shell electrons. So sodium will have a greater shielding effect than lithium, and potassium will have a greater shielding effect than sodium. As a shielding effect increase, it will become much more easy to remove electron. So amount of shielding effect increase, the ionization energy decreases. And as the electron is far from the nucleus, ionization energy decrease. So 2 and 3 are explaining that ionization energy, why the ionization energy is decreasing as we go down. What about the fourth one? Number of unpaired electron. About the number of unpaired electron, the last shell, they all have 1 electron. So that is like the number of unpaired electron is not changing for the last shell. So that's why this factor does not explain the change in ionization energy. So if the electron is further from the nucleus, ionization energy will be lower. That is what happened and in group 1, and same thing, more inner shell electrons, so ionization energy will be lower or decreases. So 2 and 3, like statement 2 and statement 3 are explaining why as we go down the group, for group 1, the ionization energy decreases. Separate sample of some halogen alkane were dissolved in ethanol and few drops of silver nitrate was added. The faster reaction of halogen, quicker the precipitate form. Which of the halogen alkane react fastest? Look, they are identical. The only difference is the halogen. Fluorine, chlorine, bromine, and iodine. So we know because iodine, carbon iodine bond has a lower enthalpy change because iodine is larger in size. So it can easily break the bond. Or iodine bond is weaker. That's why this will be the fastest one. Which of the halogen alkane react fastest? This is about the branch one. If we have a tertiary halogen alkane, a halogen alkane which is having more branches, the bond will break easily. So when we check, when we draw this structure, it will be CH3, CH, Br is there, then CH, then CH3, and then CH3. When we check the carbon, this carbon has two carbon chains, so it is a secondary. If we the tertiary compounds break down or react much faster than secondary, and the secondary compounds react much faster than primary. So this is a secondary. So it's not an answer. We will look for tertiary. When we check option B, which is CH2, CH3, CH2, CBr, CH3, and CH3, because this CH3 in a bracket, so it is connected with a carbon. So this carbon, which is attached with bromine, it is having three carbon chains or three alkyl groups around it. So it's a tertiary halogen alkane, and the tertiary halogen alkane react much faster than secondary or a primary. That's why B will be the right answer. Other like example, why not C? If it is CH3, this is CH, then we have CH2, Br, and then we have CH2, CH3. So when we check this carbon which is attached to a bromine, this carbon is attached to a bromine, it has only one carbon chain. Like around it, only one carbon chain, so it's a primary. And same thing, this one is also a primary. So remember, tertiary halogen alkane react much faster than secondary, and secondary react much faster than primary. So we are looking for the fastest, so we are looking for the tertiary halogen alkane. What is the structure of 2-bromo, 3-chloro, 2-methyl butane? So we name each of them to identify. So whenever we name, we select the longest chain of a carbon. Always the rule is select the longest carbon chain. So we select, like example, 1, 2, 3, 4, 1, 2, 3, 4. So this is the longest chain of the carbon. Numbering should start from a nearest branch. So if I number the carbon atoms, this will be 1, 2, 3, 4. So second position, I got a branch. But if I number from here, 1, 2, 3, 4, second position, I will have a branch. But here, why we number from the left-hand side? Because when I number from the left-hand side, there are two branches. If I number from the right-hand side, only one branch. So it means this is, and when we name them, we name according to the alphabetical order. The branches, it's not about position, it's about alphabetical order. So B is first, so it will be 2-bromo. Then C is there, so 3-chloro. Third position chlorine, so 3-chloro. And second position, we have a methyl, so 2-methyl. And then 1, 2, 3, 4. So it will be but and single bond N. So 2-bromo, 3-chloro, 2-methyl, butane. So A will be the right answer. Why not B? Like we select the longest chain, 1, 2, 3, 4. So here, when we number like 1, 2, or here we'll number from this side, so 1, 2. Second position, we have a chlorine, so but we need third position chlorine, that's why this is wrong. Here, when we select 1, 2, 3, 4, 1, so here we select, but we have two methyl groups as a branch. But here we have only one methyl, so this cannot be. When we select 1, 2, 3, like 1, 2, 3, 4. So second position, we have chlorine and bromine, but we want third position chlorine. That's why this is not correct. So A is the right answer. Is it clear? Which of the structure represent the primary halogen alkane? Primary halogen alkane means the carbon which is attached with the halogen is having a one alkyl group. That will be a primary. So when we check, say this is a carbon, so two carbon chains are there, so this is secondary. This is a carbon which is attached with chlorine. It has three carbon chains, so it is tertiary. This is a carbon which is attached with halogen and it has only one carbon chain, so this will be a primary. And this is a carbon which is attached with halogen. It has two carbon chains, so this will be a secondary. So we are looking for the primary. That's why C will be the right answer. And when we talk about the rate of the reaction, B will react much faster than A and D, and D will react, A and D will react much faster than C. So tertiary react faster than secondary and secondary react faster than primary. The percentage transmission is given. Which could be an infrared spectrum of CH2. Which could be an infrared spectrum of CH2 double bond CH and then OH is there. So usually they provide a data booklet because wave numbers are not supposed to memorize the wave numbers. Or either in any of the question it might be given. Just let me check. Because without knowing the wave number, you cannot predict the percentage transmittance. So it's not given in this range, it's not given. So, but because the wave number should be given, without a wave number, you cannot identify the molecule. So, which could be in either the exam, because usually when they provide the data booklet, they just take it back. You're not supposed to carry it home. They give you the data booklet during the exam. If any question is there related to a data booklet, they will provide and they just take it back. So for this question, it can only be done with a data booklet because without a wave number range, using a data booklet, you will find what is the absorption for C double bonded with C and what is the absorption for OH. So C double bonded with C and OH absorption, you will look that and you will work out which spectrum is this. So I'll just check the examiner report about this and I will come back to this question because without a data booklet you cannot solve this question or without knowing the percentage without knowing the wave number or wave absorption. In question 13, the mass spectrum of propanol is shown. Which fragment is 43? So you just have to add if you have a propanol is CH3, C double bonded with O and CH3. So this one is 12 plus 3, 15, 12 plus 16, 28 and 15. So you will get a P 12 plus 15, which makes 43. So 43 is due to CH3, C double bonded with O and plus. This will give a total sum will be 15 plus 28, 43 will be there. So CH3CO, so B will be the right answer. Because it's about propanol, not propanol. Propanol is there, which has 3 carbon atoms are there. And in which one of them is C double bonded with O. In question 14, 4 mole per dm cube solution of an acid is used to prepare dilute solution of an acid. What is the volume required to make up to 150 cm cube? So we want to change the concentration. So first, this is the original concentration of an acid. And used to prepare a dilute solution, a new concentration is 0.35. And what volume of a water is required to make up to 150 cm cube? So first, what we can do, we can simply work out. Here we have the concentration and here we have the volume. So we work out the moles. So moles equal concentration into volume. Like this is a new solution which we want. We want a solution of 150 cm cube which has a concentration of 0.35. So 0.35 multiplied by 150 divided by 1000, because the volume should always be in decimeter cube. So it should be 0.15 times the concentration 0.35 0.15 times 0.35. So we want how many moles? We want 150 divided by 1000. So we'll get the moles, which is 0.0525. We want these moles. And original concentration of the solution was this. So what was the original volume? So how to work? Same formula you will use. Moles equal concentration into volume. If you need volume, volume will be moles divided by concentration. Because the two solutions, original solution and the diluted solution, they will have the same moles. The only difference is the volume. So 0.025, the concentration was 4 into volume. So this answer, what we get, we divided by 4. So if we divide by 4, we get 0.0131. That will be the volume in cm cube. To convert into decimeter cube, 25 is also there. We'll multiply by 1000. So 1, 2, and 3. So this will be 13.125. So original solution 13 point. This was in dm cube. We multiply by 1000 to convert into cm cube. So this was the original solution volume, and this is a new solution 150. So the question is, how much water should be added? So how much water must be added? Because the original solution was having a volume of 13.125 and the new solution has a volume of 150. So what you have to do, you just have to subtract. So minus 150, 150 minus this answer. So you get 136.87. So 136.87, which is about 136.9. So D will be the right answer. Is it clear, this question? So first, we have the volume and concentration. We work out how many moles are there in our final solution. And the moles in the final solution will be there, moles in the original solution. And from the moles of original solution and the concentration of original solution, we worked out what was the volume of the original solution. But the question is not what is the volume of original solution. The question is how much water should be added to the original solution so that it become dilute to 0.35 mole per dm cube. That's why we subtract the two volumes to know how much water must be added. We can dilute the solution by simply adding a water. So pellet of a sodium has a mass of 0.7. Some pellets were dissolved. How many pellets were dissolved? So we have the concentration, we have the volume, and we have 0.25. So using the concentration and the volume, we first work out the moles. So 0.25 multiplied by 350 divided by 1000. So 0.35 multiplied by 0.25. 0.087. 875 moles are there. And then how much, how many grams to multiply by molar mass, which is 40. So it will be 3.5. So 3.5 grams, the total mass. So how many pellets? Each pellet has a mass of 0.7. So 3.5 gram is the total mass, and the mass of one pellet is 0.7. So if we divide this by 0.7, we get how many tablets of a sodium are added. So 5 tablets of the sodium are added. Then 25 cm cube of solution of a sodium hydroxide placed in a conical flask. Calculate the number of moles of sulfuric acid. So this was 350. And 25 cm cube of solution is taken out. Out of 350, we just took 25 cm cube. The moles which we worked out, so it was 0.35 times 0.25. The moles were 0.087. So there in 350, 0.087 moles, 875 moles were there, which were in 350. But we only took out 25. So 350 contained this many moles. So if we just took out 25, how many moles of sodium will be there? X. So it will be multiplied by 25 and divided by 350. So the moles of sodium hydroxide which we are using for the experiment are 0.00625. These are the moles of sodium hydroxide we are using. And we'll use a ratio of sodium hydroxide and sulfuric acid. The ratio is 2:1. So if we have 0.006625, so this will be X. We cross multiply. So it will be divided by 2. So we get 0.0031. So these are the moles of the sulfuric acid which are used for the reaction. And when phenolphthalein is used as an indicator, because originally it was alkali, and then so phenolphthalein is colorless in acidic, and alkaline it is pink. So originally it was alkali and then become alkaline. So it is originally it is alkaline because sodium hydroxide was in the conical flask. So the base was in conical flask, and then we add an acid. So final color should be in acid and original color is in alkaline. So that's why it will change from pink to colorless. And concentrated aqueous ammonia, which one will dissolve? So silver and they both will dissolve. And 3 grams of a lithium. This I will solve. Less than a minute left. So I'll share another link and solve this question.